Welcome to Concept and Coding, and this is Shrayansh, and in the low level design video today I am going to cover all structural design pattern in just one video, right? So we already know what is a structural design pattern, right? And before I even start, I just want to say one thing, that I have already covered each structural design pattern in a dedicated video. Okay, so here I will cover all 7 different type of structural design pattern, but still if you see any doubt, please go check out the dedicated video for that particular pattern, right? Okay, with that being said, I'll start. So we all know what is structural design pattern by now. So structural design pattern is a way to combine or arrange different classes and objects together, right, to form a complex or bigger structure to solve a particular requirement, right? So we have different classes and different objects. So in a structural design pattern, we arrange them in such a manner. And when I say that arrange, what do you mean by? So it should be composition, usage of inheritance, right? Is a has a relationship. So combine different classes in such a manner that we construct a complex structure of those classes, and which is required to solve a particular requirement. Okay, so that is what is known as structural design pattern. So there are 7 different types of structural pattern: decorator, proxy, composite, adapter, bridge, facade, and flyweight. So let's check each one of them. First is decorator pattern. So this pattern helps to add more functionality to existing object without changing its structure. Okay, so just concentrate more on this, to add more functionality to existing object without changing its structure. Okay, so I have explained this decorator pattern with an example of pizza, if you remember, right? So let's say we have base pizza, right? Base pizza, let's say it's veg delight. Okay, now you can garnish it with extra cheese, right? So what it is saying, that add more functionality to existing object. So I am adding more features to an existing object. So base pizza is my existing object. I am adding more features: extra cheese, add mushroom. Now I can add more cheese. Now I can add more mushroom or some other veggies, right? So I keep on adding extra features on the very base object itself. Okay, so if you see that I am not even changing the base pizza, which is of my base object, but I keep on adding more layers of the feature. That's what decorator pattern says, that add more functionality to existing object without changing its structure. So how we gonna do that? Just see this example. So here I have created an abstract base pizza, right? So there in the, this is my base pizza. So I have created this an abstract class. So there can be different type of base pizza. So veg delight is one, let's say farmhouse, margarita. So there are different type of base pizza. So I have created 2 classes, 2 concrete classes of this base pizza. One is farmhouse, which extend this base pizza, and one is margarita pizza, which extend this base pizza. So it's a ISA. Okay, so it has one abstract method, cost, and this farmhouse is implementing that abstract method, and it is, let's say it is of 200 rupees, margarita is 100 rupees. So this is very base object. Okay, now I want to add additional feature, right? So once I have created, let's say farmhouse, now I want to add additional feature to it, like add more extra cheese or add mushroom, or there can be multiple combinations, right? So that's where the decorator pattern is used. So what I have done is I have created an abstract class with the name topping decorator, right? And if you see this, notice one point, it is also extending the base pizza. Okay, so whatever the base pizza is and whatever the topping decorator you are creating on top of it, so that itself is a pizza. So that also is a, that's also is a pizza. So whatever the topping decorator you're gonna do, it is also is a pizza itself. Okay, and I have, so it has two childs. I have created two type of topping decorator. One is extra cheese and one is mushroom, right? So they are extending the topping decorator, and inside this I have the base pizza. So that's why I kept has a. It has, so it has both the relation is a and has a. So this topping decoration is a base pizza, and this also has a reference to the base pizza. So now in the extra cheese, what I am doing is I have a base pizza reference, right? And I use the constructor to initialize this base pizza, right? So it can be either margarita or either it can be farmhouse, whatever it would be. And how cost I am adding it, whatever the base pizza cost is, I am adding 10 rupees to it, extra cheese. For mushroom, the same thing, I am adding 15 rupees. So now let's take this example. Now understand this, multiple layers. Now let's say you have mushroom, you have extra cheese, you have veggies. So now if you don't have this decorator pattern, how you will gonna create it? Let's say you will create only, let's say, margarita. You can have one class like margarita plus extra cheese. You can have one class like margarita plus mushroom. You can have one class like margarita plus extra cheese plus mushroom. Somebody want 2 times extra cheese, double cheese, right? Margarita plus extra cheese plus mushroom. Now I have farmhouse. So now I have the same different classes for farmhouse also. Farmhouse plus extra cheese, farmhouse plus mushroom. Now if you see that, if there are, let's say, 10 toppings, then you will, if you go with this approach, if you create a class for each combination, you will get into another problem which is called as class explosion. To save this class explosion, that's where the decorator pattern, what we have done, helps it. So it separates your base pizza and separates the topping decorator. If any more topping decorator exists, add it here, mushroom, extra cheese, veggies or whatever. So this topping decorator itself is a pizza. That's why itself is a pizza, and it also has a reference. Okay, so whatever the base pizza you will create, it will append to it. So I am just taking a feature of cost. So whatever the cost it has, it append to it. So now let's see how I am creating. So here I am first creating a farmhouse. I am first creating a farmhouse pizza. So this is my farmhouse pizza. Then I am layering it with extra cheese. So I have added extra cheese. Okay. Then I have layered it with mushroom. So I have a mushroom here. Okay. So now this is my pizza. If I do pizza dot cost, right? So it would be farmhouse was for 200, right? So extra cheese, in the extra cheese, in its constructor, I send the farmhouse object. Base pizza was the farmhouse. So base pizza dot cost. So farmhouse was 200 plus 10. So 210. And this 210 rupees I pass to the mushroom. So in the mushroom constructor, I pass this base pizza, right? So itself, topping decorator, it's a pizza, extends base pizza, right? So this itself is considered as a base pizza. So its cost, so 210 plus 15. Okay, so this is your ultimately pizza cost. Got it? So this is your decorator pattern where you add more functionality to an existing object without changing its structure. Now let's see the second one, proxy pattern. So proxy pattern is very, you can say that intuitive, is like somebody is in mid between your client and the resource which you wanted to access, right? So this is you and this is the ultimate resource which you wanted to access. So there is one proxy in mid. Okay. So whatever the request goes, it goes through proxy, and proxy will send to the resource. Whatever the request comes from resource, it goes here and goes this. So here, this pattern helps to provide control access to the original object. So it provides some control access to original object. So it can take like who can access the resource, who cannot access the resource, or before accessing the resource, if I have to do perform tasks like logging, right, or some other any task, certain validation, it can do, right? So let's understand with a very, very simple example. I have created an interface employee DAO, right? You know, right? DAO, what is DAO? DAO is data access object, which is used to access the DB. So let's say you have employee table. In Java, you create one DAO class, which employee DAO, which access this table, right? Just basic information like what is DAO classes are. So now let's say I have created an interface called employee DAO, and I have exposed one method create. Okay. So now I have two child classes of this interface, two implementation of this. One implementation is employee DAO IMPL, which is your original object. And I have also created a proxy, right? So I have also created a proxy, and this proxy has the original object. This proxy has the original object. So I have created an object of IMPL, this one. Okay. And now whenever anybody creator wanted to call this employee DAO IMPL create method, it has to first pass through from this proxy, right? So I am creating an object employee DAO. I have created an object. So this is an interface, right? It can be, so this reference, interface reference can hold a reference of this objects, right? So I am creating an object of the proxy, new proxy. So I am creating an object of a proxy and calling the create method. So calling this create method. Now, when you invoke this proxy object, what will happen is it has the reference of this original object. And when we call the create method, so what it do is it do certain validation. So just for example, I have added, if the request is from admin, if it's an admin call, then invoke the original object. So now it is invoking the original object, this method. If this call is not from an admin, throw an exception. So what does it say is that this pattern helps to provide control access to an original object. So now I am controlling here. If the call is from admin, then only call this, otherwise throw exception. You got it? What does it mean? Very, very simple. So here the only thing is we create a proxy also, and this proxy has this one, and it is a part of the same interface. Okay. The third one is composite pattern. What does composite pattern is? This pattern helps in the scenario where we have object inside object, tree-like structure, right? So just take this example, object inside object. So let's say delivery box. Inside delivery box, you can either have the item, or generally I call this as the leaf. So in the tree, one you have is parent node and other you have is a leaf node. Leaf node means they are the end nodes. So that's where in the composite also, where we have to solve a scenario where we have object inside object, tree-like structure. So delivery box can either have item, and once you got the item, you can't have another delivery box, right? So it's generally known as leaf. And delivery box can also have another delivery box. So the same thing, now a recursion, delivery box can either have an item or it can have a delivery box. Similarly, it can have either an item or it can be a delivery box. Okay, so these items are generally are leaf nodes, you can say that, and this delivery box are nothing but a composite objects, right? Object inside object. Another example is file system. Let's say I have a file system. Inside this file system, either you can have a file, which is a leaf, or you can have a directory, which is a composite. And this directory can again have either a file, which is a leaf, or can again have a directory. Then this directory again can have a file, or again have a directory, like this goes on. So this is just an example to identify the scenario where the composite pattern can be used, like object inside objects. So this is the UML diagram, like your component, which is an interface, and there is an operation. So either it can have a leaf concrete class operation implementation, or either it can have a composite. And if it is a composite, it's a recursion kind of thing. We'll see with an example. So now let's take this an example of a file system. So I have created an interface file system. Okay, so this ls is used to print, right? Let's say it is used to print. So I am using this method which is used to print the file name, let's say. So I have created an interface file system, and one part is the leaf part where this file system directly have a file. So I have created one file which implements the file system, and this implement this abstract method and print the file name here. Let's say anything, whatever the file name would be, let's say it print here. But another possible use case be, instead of file it has a directory. So now it has a directory. So directory implements file system, right? So it is the. So inside a directory, what should be the implementation is, directory have a list of file system. It is a list of file system, right? So let's say you have a directory A. So directory A can either have file, either have can more directory, directory B, directory C. So it can have a list, right? So list of file system, and list of file system means it can be a file, it can be directory, and there can be more than one. So I have added one method is add, right? So because in a directory you can add either file or directory, either file or directory, either file or directory. You can add more file or more directory, right? So whatever the file system would be, because file system is an interface, it's a parent. So either you can have a file or either can have a directory. So you can add into the list. And whenever the ls implementation, what I have to do, so whenever the ls in a directory happen, ls, what it has to do, if it is a file name, so I have to iterate over this list, and if it is a file, I have to invoke the file one, this one, and if it is a directory, I have to do the same thing again, because this directory itself internally can have a file, directory, file, directory, like this, right? So the same iteration has to be done for it. So the same thing I am doing it. So in the ls part, what I am doing is, I am iterating a for loop. I am iterating over the list. I am iterating over this list, right? And I am just calling this ls. So now let's say if it is a file, it will invoke this ls and it will print the file name. And let's say if it is a directory, then it will call this method again, because this is the directory class. If it is a directory, this will call its ls again, and it will go again for loop. So in this directory, whatever the list would be, it will first complete that. Then it will, after completion it will move forward to here. Okay, got it? So this is just an example for it. Learn, I have created a directory, parent directory, Inside the parent directory, I have added one file, file1. Then I have created child directory. Okay, then I have created a child directory. So this is your parent directory. So it has file1. Then I have created child directory. In the parent directory, I added the child directory. And this child directory has file2. This has file2. That's all. So now I am doing parent directory.ls. So I am doing ls here. Okay. So it will iterate over this. First it will go here. It will print this. Then it will go here. And it will call ls here. So it will now go to its child. So it will print f2 also. Okay, got it. So it's a kind of a recursion and very simple to identify where to apply the composite pattern. Okay. The fourth one is adapter pattern. So very simple. Understand this pattern act as a bridge or intermediate between two incompatible interfaces. Okay, so this is an example. You have a client which wanted to access this adaptee, but see, client has this kind of a structure, adapter is this kind of a structure, both are incompatible. So that's where adapter comes into the picture. So client calls adapter, adapter calls adaptee, like whatever the adaptee understands in that manner. Adaptee returns to the adapter, adapter changes the response whichever the client understand and return it. Okay, so it is a mediator now. So understand this with a very simple example. I have created a weight machine interface, let's say. So this machine returns the weight in pounds, right? So this is just an interface. I have implemented it. This method get weight in pounds. Let's say it is simply returning 30, right? I have hard coded it. That's return 30. So this is returning in pounds. Now I have a client which want in kg, right? But client only understand kg. It doesn't understand the pound. So that's where I have created one adapter. So I have created one interface and name it weight machine adapter. So its method is get weight in kg. So now it is just a mediator between the client and adaptee. And this is your adapter. So I have implemented this adapter. So now this adapter has your adaptee. So it has an object of weight machine. Okay. So this is just a constructor to initialize this weight machine with the IMPL objects, right? With the IMPL object. Now when the object is constructed, when this get weight in kg, so client will invoke this. Because client cannot interact with this directly because client understand only in weight, but this adaptee returns in pound. So client is invoking this adapter get weight in kg. Internally it invokes this get weight in pounds. So it has weight machine. So it calls get weight in pounds. It convert it to a weight and then return it. And then when client get received in the kg itself. So client is creating an adapter. So client is talking to an adapter, not with the adaptee. So client is talking to an adapter. So it's creating a new adapter object, right? New adapter IMPL. And weight machine, it pass an object of this IMPL, right? So now it calls get weight in kg adapter. So this method get invoked. It will first call the pound method, this one, convert it to kg and then return. Okay, so it's become just a mediator adapter pattern. Okay, now another one we have is called bridge pattern. This pattern helps to decouple an abstraction from its implementation so that two can vary independently. Let's understand this with an example. So I have taken an example of a living things. I have created one abstract class living thing, and what one of the action which living thing do is breathing. So I have added one abstract method is breathe process, and I have three child classes of this living thing. One is dog, is the child of living thing, extends living thing. Another is fish, another is tree. All three are living things, and they are extending this living things abstract class. So all are implementing this breathe process. And breathe process is dog breathe through nose, inhale oxygen, exhale carbon dioxide. So this is the breathing process of a dog, let's say. And the fish is breathe through gills, absorb oxygen, release carbon dioxide. For tree, breathe through leaves, absorb carbon dioxide, release oxygen. So these are the different breathing process. But now let's say how you would add a new breathing process without adding any class of living thing. Now let's say I want to add another breathing process there. Let's say breathe through, let's say another way, like narsal, right? So the birds have nars, right? So breathe through nars and inhale oxygen, exhale carbon dioxide. Okay, so this is another breathing process. Let's say how you would add it. So you have to first create bird as this one and then add this breathing process here. So now here you see that it is very tightly coupled. So that's where bridge pattern say that decouple an abstraction from its implementation so that both can vary independently. Okay, so breathing process, let's say this is an implementation. So currently it cannot vary or it cannot increase without increasing that class, without adding that class. You can't add another new breathing process until and unless there is no class which is using it. Okay, so that's where the bridge pattern says that decouple it. And how to decouple it? So here if you see that everything is same, but what I have done is I have added a breathe implementer. So again I have an abstract class living thing, right? So just see that living thing has one method called breathe process. Same dog is a child of this, dog, fish, tree, same three classes, and the same methods breathe process they have implemented. But what is the difference now? So here if you see that this logic breathing process I have taken out from this abstraction, right? So I have created one breathe implementer. I have created one breathe implementer interface, breathe process. And what is that? One of the breathe processes like land breathe, which is a child of this one. So here in the land breathe through nose, inhale oxygen, exhale carbon dioxide. Water breathe class, breathe through gills, absorb oxygen, release carbon dioxide. Tree breathe is like breathe through leaves, absorb carbon dioxide, release oxygen. So now here this living thing has breathe implementer. So it has breathe implementer. This is just a constructor to where child whichever they wanted they can set this breathe implementer. So the dog here, this is the constructor, and during the client whatever the breathe implementer would be passed, it will get set here and it will call this breathe process. Similarly in the fish I am using this breathe implementer and call the breathe process. So one thing you should notice now, I have removed this logic out of this class, put into another interface and its child classes, and now it has this and calling that one. Now what will happen? Now let's say if I want to add more breathe process, I can add it simply. I can add more breathe processes. I don't have to worry about adding bird and then add a new breathe process. No, maybe in future I will add it, but this can scale independently. This can scale independently. This can scale independently. So I have decoupled it. Okay, so just take this example. I am creating a living thing fish object. So I am creating a new fish object, and in the constructor I need to pass breathe implementer. So fish required water breathe implementer. So I am passing new water breathe implementer. So this will get set to this breathe implementer. Now I am calling fish object breathe process. So in the breathe process, breathe implementer dot breathe process. So what is the implementer we set? Water breathe 1. So it will implement this. Right? So now here if you see that both can scale independently. If I want to add more, it can grow independently without even this class. And if this want to grow, it can grow independently without even worry about this class. Okay, so that is what known as bridge pattern. So another we have is facade pattern. So this pattern helps to hide the system complexity from the client. Understand this again, hide the system complexity from the client. Facade. So I will explain you with the two example. Let's say this example 1. Expose only the necessary details to the client. So assume this, I have one class employee DAO. I have 3 methods: insert, delete, update by ID. And I have a client here. Client, I want to only expose this method, insert method to the client. This client, employee client. I don't want to expose this 2 methods. How can I do? I can use employee facade in the mid. So employee facade has your DAO and use this constructor to initialize it, and it only has void insert method, and it is calling the insert. So your employee client cannot have access directly to the employee DAO. It can, but it will add extra overhead to the client. So we wanted to make client very don't have only expose things which is required, right? So here facade can help client that okay, you only have to worry about this insert. There might be 100 of methods here. You don't have to worry about this. Whatever is present here, you only require that. So here I created a facade object and call the insert. Okay. So here if you see that this employee client, for this employee client only insert method is exists. It don't have to worry about this employee DAO. So here with this facade, what I am achieving, expose only the necessary detail to the client. Unnecessary detail which client don't even require, I hide it. Second example, what is the facade can be used? Hide the system complexity from the client. How? For example, this is a very, very complex system, AC. We have a AC, right? Air conditioner. Let's say this is very complex system. AC has external unit class, AC has internal unit class. There are so many methods inside: check voltage, consume nitrogen, start condenser. AC internal unit has accept user temperature command, accept user on command. So there are, I just created a random classes and the methods, but what I wanted to tell is let's assume that there is one complex system exists, right? And to perform a particular operation, there could be a sequence of steps you have to perform in a multiple classes. So if client has to directly contact with this complex system, and let's say it has to turn on the AC, then there might be it has to perform several steps of external unit, internal unit, external unit, internal unit. It has to know about all these steps, then only AC will get turned on. And in future, if it is possible that if with any update, any of this step got removed or any of this step got added new, the client will break. Client has to change it. So what facade, with the help of facade, what we can do is we can abstract this complexity of the system from the client. So facade can have this all this logic. So it has, let's say, whatever the complex system required, it has those objects, and whenever turn on button has been clicked, it will do all the steps which is required to turn on the AC. For the client, interact with the facade, and it will just say that, hey, turn on button, click, turn on the AC. So this, all the step will be performed by a facade and AC will be turned on, but clients doesn't have to worry about it. If in future any change gonna happen, it will change only in the facade layer. If there are too many clients, no client will get impacted. Okay, so you got it right. What is the use of the facade? It used to help hide the system complexity from the client. Then the seventh one is the flyweight pattern. This pattern helps to reduce the memory usage by sharing data among multiple objects. So flyweight pattern is used to reduce the memory usage. Let's understand with an example what is the issue which is flyweight is trying to solve. Let's say I am building a game, and in the game I have to create a robot. I have to create two types of robot. One is humanoid robot and one is robotic dog. One is robotic dog and one is humanoid. So here if you see that I have created one robot class and I have like x-axis, y-axis in the screen where to display that robot. Type of a robot may be a humanoid robot or robotic dog, whichever you want to type, and the sprite. So here the sprite is generally nothing but in a computer graphics. It is a 2D bitmap array, right? So it is generally used to 2D. You can say that it's a bitmap which is used to render the image. Okay, so I have one sprite for this type. So now in the robot, I have this is the constructor. I have initialized this all. Now I have to create an, let's say in the game I have to create an army of robots. So I have to create 5 lakh humanoids and 5 lakh robotic dogs, right? So maybe robotic dogs I have to create so many. So here what I'm creating is I'm creating a for loop for 5 lakh times, and first I am creating a calling the robot 5 lakhs time, its x-axis, y-axis, right, where I wanted to place them. What is the type? Humanoid. I wanted to create a humanoid type and I pass the humanoid sprite. So let's assume that this is object which has the graphic rendering information 2D bitmap array to draw the humanoid. And similarly I have running the loop for 5 lakh time for the robotic dog, this thing. Now let's say now I am creating 10 lakh objects, 5 lakh robotic humanoids, human robots, and 5 lakh robotic dogs, right? Total 10 lakhs. Now but one object is taking how much memory? Let's say that. So integer coordinate. So it is an integer, let's say 4 byte. Integer y-axis again 4 byte. Let's say type. Let's say it is of 50 character. One character is 1 byte. So let's say it is 50 bytes. And sprites body. So this is one, let's say, heavy object where we are rendering 2D bitmap array. So let's say it is 31 KB. So let's say overall this object is around 31 KB nearly. Now if I am creating 10 lakh objects, so 10 lakh into 31 KB, which is, let's say it's equivalent to 31 GB, let's say. But let's say we have only 21 GB memory, and we are creating so many objects which is almost consuming 31 GB, then it's an issue. We have only 21 GB, but we have created so many objects that it consumed 31 GB, then it's an issue, right? So how to resolve it? Flyweight pattern helps it, because it helps to reduce the memory. How? It has two parts. One thing you have to look at is in-string data. What is in-string data? In-string data is shared among objects. So look for any data. Okay, I want to create an army of, let's say, objects. Let's say this is humanoids. I have to create 5 lakhs. So many objects. Just look for, is there any properties shared among all of this? Is there any shared data? Yes, there is shared data. So all are humanoid, so their type is same and their 2D rendering is same, like the graphics is same. They all look same. So the type and body is same. So these two are in-string data. The properties which are shared among the objects. Okay, and once they are defined, they will remain the same. Once they are, whatever the value is defined at once, their values doesn't change actually. They always look same. Then another second part we have is in-string data. So this value or property change based on the client input. So here if you see that x-axis and y-axis is provided by the client where to place them. So this is in-string data, right? So this will change for every object. So maybe this object is placed at 1,2 axis, this can be placed at 5,6. So this will change for each of the objects. So that is x-string data. So if an object has both these two, in-string and x-string, then flyweight pattern can be used to save the memory. Okay. So how? Let's now see that how we can do that. So let's see this an example. So I have modified the previous class, like I have created an interface robot. I have wanted to create a two type of robot. One is humanoid robot and one is robotic dog. So this implements the robot. Okay. So in this object, what we have to keep only the in-string data. Keep only in-string data. What is in-string data? Properties which are shared among different objects. Okay, so type and body is something which was same for all different objects, no matter how many create. So that's our in-string data. So whatever the objects which you are creating, keep only the in-string data. So this is just a constructor to initialize those. And the display method, right? And now display method and where to display x-axis and y-axis, right? So now here if you see that x-string data is passed in the parameter, right? So now two things which we have done is, from the object remove all x-string data and keep only the in-string data. So from the robotic object I have only kept the in-string data. I have removed all the x-string data, and whatever the x-string data is, you have to pass it. In-string data can be passed in the parameter, right? And the class which only has in-string data, that is known as flyweight class generally. Okay, so first step is, this is the first step, that create your class as an flyweight class. In the flyweight class you have only in-string objects, in-string properties, and wherever you want string properties or the properties which should be sent by client, pass this in a parameter. Okay, so one thing, I have modified this robot class like this. I have kept only the in-string in that one, and in the display part which was required, I have put pass the parameter as all the x-string data. Similarly I have done for robotic dog also. Okay, so I trying to enhance it. Even I have created a one class, itself we have a type, right? It can determine, but just wanted to use an interface so that humanoid robot, robotic dog, in future if any they have a unique behavior in the display, they can have it, right? But understand that from that perspective is in the class robot class, now we have only string data, and the method which have to work on the string data, we have to pass it through parameter. So first step is completed, that the object need to be a flyweight, the class has to be converted into flyweight class. Second, this flyweight class or this flyweight object which we will construct, we have to store it in somewhere, right? So that they can be reused. So now what I have done is I have created one, let's say hash map, kind of a cache. So I will store it. Okay. So here I have one create robot method, right? And have a robot type as a parameter. So here first I am checking if robot type contains this, if this cache contains this robot type. So I am distinguishing this cache on the basis of type. Okay, humanoid or robotic dog. Two type of robots are exist, right? Humanoid or robotic dog. So type. So in the key, in the hash map, the key I have used the type, whether a humanoid or robotic dog, and the flyweight class object, this one, because this is something which is very, very expensive to construct a sprite. Okay, so first whenever the create object request comes in based on the robot type, I will first check my cache. If the cache has this robot type, if yes, then I will return the same object. So now let's say if I have constructed one object for humanoid one time and I have put into the cache, right? So this is an object of humanoid and the map, and so this keyword is, let's say type is humanoid, and let's say this is type is robotic dog, and it has one object, robotic dog. So one time constructed. So whenever the second time will come, we will check into the map, hey, is this type already exists? If yes, return the same object. So now we are reusing the object. Okay, but let's say if the cache is empty, right? So what we are doing is if the type is humanoid, we are creating a humanoid sprite, right? And we are creating a humanoid object, putting into the cache and returning. Similarly, if it's a robotic, we are creating a robotic object, passing the type as a robotic dog and robotic dog sprite, putting into the cache and return it. So understood it? What we are doing is we are caching it. Okay, so only one time we should be having it, and we should reuse it whenever it is required. Now see in the client side how I am using it. So let's say I am creating a robot factory, create robot humanoid. So I am giving a command, hey robot factory, create a robot humanoid. Robot factory, it will create robot humanoid. So initially it would be empty. Robotic cache is empty, map is empty. So it will go inside this, okay, humanoid. So it is now constructing a heavy expense objects. It will creating a sprite for the humanoid. It is constructing the humanoid robot. It create an object. Now it put into the cache, right? And the robot type. So robot type was humanoid, and it returns it. And I've displayed it at 1,2. So in a screen, let's say this is 1, this is 2, 1, 2, 3. So 1,2, I have displayed one robot. Now I am creating another robot. Robot factory, create robot humanoid. Again, create one more object. So now it will check the cache first. Hey, does it contain robot type? Yes, the cache has this humanoid already. Return the same object now. So now here if you see that I am not creating another sprite and all, because you know that this is something which is very expensive, but I am not creating it. So I return the same object I return it. Now I am using that data to display that at 10 comma 20. So let's say this is 10 20, so I am displaying it here. Using that 2D bitmap array, I'll draw it here. Okay, so now you see that what we have done. So in the flyweight pattern, it helps to reduce memory usage by sharing the data among multiple objects. And how it will share it, just see these two things in a particular thing, in string data, x string data. If these two things are present, means we can use a flyweight pattern. From a class, keep only the string, x string data, pass it into the parameter and use it. And you might have to use the caching so that the objects can be reused whenever required. We don't have to create a separate object every time. Okay guys, so these are the 7 types of structural design pattern. I might be little bit quick here, but if still you have any doubt, please go ahead and check the dedicated video out of it. And in the description section, I will just share this doc link. Okay guys, happy learning and bye.